Hi everyone, and welcome again to Last Minute Maths with another Olympiad question, another one of these algebra ones. And as in the previous video I did on the Olympiad questions, I'm going to assume some basic factorization knowledge and so on. If there's any questions on that, please do leave it in the comments and I'll be very happy to explain further if necessary. All right, on that note, let's go straight into it. So we're solving two simultaneous equations. As you can see, the first one is x to the power 4 minus y to the power 4. Second one, equation 2, is just x plus y equals 1, a linear. All right. So what we're going to do first is to use difference of squares, and we're going to do it twice. I'll explain what I mean by that. First time, we're going to split the x to the 4 minus y to the 4 into their sort of square roots in difference of squares. So remember that the square root of x to the 4 is x squared. All right. So we get x squared minus y squared and times x squared plus y squared equals 5 from equation 1. And from there, we know that the x squared minus y squared itself can then be broken down into x minus y, x plus y. All right, two factors. That's what I meant about doing it twice. So now that we have that broken down into x minus y times x plus y times x squared plus y squared all equals 5. We then remind ourselves that from the original equation 2, x plus y equals 1. So therefore, that middle bracket, x plus y, disappears, just equals 1. So we can ignore that for now. Simplify the whole thing down, and we get x minus y times x squared plus y squared equals 5. Then we're going to use the result from equation 2, rearranging it to get y on its own. So just put that there. Rearrange equation 2. All right, y equals 1 minus 1. And then sub back into wherever we see a y. And substitute back into equation 1. All right. So as you can see, I've replaced the y in the first bracket with originally 1 minus x, but there was a minus in front of it. So just to explain this, it's x minus 1 minus x. That is x minus 1 plus x. All right, just in case that's confused anyone. And in the second brackets, it's got a y squared. So I've got 1 minus x all squared within the bracket. So now I'm going to go ahead and rearrange everything and expand brackets out, get rid of any internal brackets. The first one simplifies to 2x minus 1. The second one, again expanding the 1 minus x out, it gives us x squared plus 1 minus 2x plus x squared. All right, and all of that equaling 5 as before. So again, collecting like terms. All right, so collect terms and then expand the brackets. All right, let's put this way. Multiply out the brackets. Okay. And I think just to illustrate, I might switch to a different color here for a moment. Let's see what's going to be a decent color to use. That one will do. We've got to make sure we cover all the possible combinations. All right. All right. So that's the way of making sure that you don't miss anything. And the first one gives us our 4x cubed. All right. Do remember that you've got a cubic there. All right, so that's fine. Next one, the 2x times minus 2x minus 4x squared, and then 2x times 1, just 2x, etc. So we just go through the process. Minus 1 times 2x minus, 2x squared gives us minus 2x squared. Then minus 1, right, watch out, and minus 2x gives us plus 2x, and then minus 1 times 1 minus 1, and again equals 5. What I've then done is brought the 5 over to this side, all right, in the next step. And so collecting all the terms together, we have 4x cubed, and then we have the minus 4x squared minus another 2x squared gives us minus 6x squared. All right, so that one. And then 2x plus 2x gives us a 4x. And then you have the minus 1 minus 5 gives us minus 6. So that's all correct there. Then we can divide everything, get rid of the factor of 2. So the equation simplifies a little further down to 2x cubed minus 3x squared plus 2x minus 3 equals 0. And what we're going to do is take these as 2 terms at a time, like this, and factorize what we can. The first one we can see has a factor of x squared in it. If you divide both those first 2 terms by x squared, you're left with 2x minus 3 with the x squared on the outside, like that. And coincidentally, as the question is meant to be, the second term has no common factor, but it is the same as the 2x minus 3 in the first term, in the first sort of combined term. So what we can now do is to remove the 2x minus 3 outside and turn that into x squared plus 1, all right, there, and then the 2x minus 3, okay. Given that simplification, we now have 2 possible solutions for x. The first one, where x squared would be minus 1, is not valid under normal terms, okay, because you're not square rooting a minus 1, okay, so that's not going to work. But I will come back to that in a moment with a slight addition to that thought. The other solution presents us with a clear, valid answer of x equals 3 over 2. Noting from the very beginning, the second equation, the linear equation, that y equals 1 minus x. Therefore, if x equals 3 over 2, y equals 1 minus 3 over 2 equals minus half. Again, presenting the solution in a coordinate fashion, you have 3 over 2, comma, minus 1 over 2. All right, so that is actually the equation solved. Those of you who are doing either A-level maths, for example in the UK, or further maths, specifically further maths A-level, that could give you complex or imaginary solutions. Roots, they're called. All right, and that's something we're not going to go into in the scope of this video, because that's not something that's required for the Olympiad questions. But they do exist if you are doing further maths. but I'm not going to, as I said, cover that in the scope of this video. Well, I hope that helped and it's made some sense. Again, if you have any questions or any other particular Olympiad or maths questions in general, GCSE or A-level, then please do drop it in the comments. I'll be happy to offer a solution to them if I can. And if you've found this useful, if you liked it, please do consider subscribing, liking and commenting. All helpful comments are very welcome. All right, well, look forward to seeing you in the next video. Thanks for watching.